Hi, in this video we will be discussing important information on Martin lighting effect systems. Luminaries from Martin currently use either electrical discharge lamps or LEDs as light sources. Due to its popularity, the MAC TW1 was discontinued and brought back into production several times because a replacement model didn't exist. Since it has taken several years to create a light output that mimics the color of tungsten, the MAC Encore LED has surpassed and replaced the MAC TW1. The models that use discharge lamps consist of the MAC Viper, the older MAC 3, the MAC 700, and even exterior products like the Exterior 1200. Utilizing LEDs, we have the MAC Aura, the Aura XB, and the Quantum Range. Discharge lamps produce light by generating lightning-like sparks between two electrodes. These lamps are 4 times more efficient than tungsten halogen lamps, as 31% of the electricity is converted into visible light. That doesn't sound like much, but when a 1200-watt discharge lamp is at 100% intensity, it's extremely bright. For discharge lamps, a mechanical dimmer system is required to control the intensity. The blades that converge block out the light, as opposed to LED sources where the power is reduced. Typically, discharge lamps give a cold light with a large amount of blue. Tungsten lamps produce light by heating a thin wire or a filament. The intensity of light can be controlled by varying the voltage. Tungsten lamps do not require an igniter or ballast, whereas the discharge lamps need both. The reason you need the igniter and the ballast in this size discharge lamp is because it takes a large amount of power to strike. The ballast is designed to provide a continuous, reliable flow of power. That's a lot of power. If the power is not stable, then the lamp may flicker. Also, with tungsten lamps, only 7% of the electricity is converted to visible light. Tungsten lamps give a warm light with a large amount of red, making these lamps very popular in theater. However, because they only give off 7% of converted light, and the lamp life is a very short 300 hours, they are an expensive fixture to continue using. For this reason, these lamps are only used when necessary, and are typically turned off immediately when not used. When powering down, you should follow the correct shutdown procedure. Discharge lamps tend to be left on so they are ready for the next show. As mentioned in another video, there are 2 different types of reflectors, one being a polished metal reflector, and the other being a polished mirrored glass reflector. The reflector is designed for one purpose, which is to direct the light forward and out of the fixture. Glass reflectors have special dichroic coatings that reflect light forward and allows infrared light, or heat, to pass out of the back, resulting in a cooler, more efficient light source. The issue with polished metal reflectors is cooling efficiency, where a large number of high-powered fans are needed, which can create loud noise. Glass reflectors are different between the wash and the profile. When viewing the physical makeup of one layer, the difference in the way they are produced can be seen. When comparing mechanical dimmers and electronic dimmers, unlike tungsten halogen lamps, discharge lamps cannot be fully dimmed electrically. The only way to control the light's intensity is to block it with a motorized wheel or a pair of flags. Most Martin products consist of a pair of flags. The flags must be calibrated so the arms know where to stop the light from escaping. The advantages of this are longer lamp life, less current draw, and no delay while waiting for the lamp to cool enough to restrike. A color filter is used to remove partitions of light from the white beam. This is the opposite with LEDs, where the process is known as additive color mixing. Martin uses color mixing that is based on graduated cyan, magenta, and yellow, or CMY filters. This is also known as subtractive color mixing, as each filter subtracts one of the primary colors from white light. The filter's strength increases as they are moved into the beam. This gives a wide range of colors and shades. The cyan flag reflects the red colors. To create a cyan beam, it removes magenta and yellow, as opposed to inserting a cyan flag that turns the beam cyan. Martin is renowned for having a very efficient color CMY mixing system. Color temperature correction, or CTC, is the change in red to blue light that is radiated by an object as it is heated. On the Kelvin temperature chart, candlelight at 2300 K or 2300 Kelvin, gives a very warm temperature, and moving up the chart, the Martin TW1 shows a warm temperature at 3000 K, or 3000 Kelvin. The reason the TW1 was so popular is because it could provide such a warm color temperature. In theatrical environments, color temperature is incredibly important, as opposed to a rock and roll environment, which is typically bright and punchy as possible. What does GOBO stand for? Well, the general consensus is it stands for Goes Before Optics, insinuating this is put in front of the optic to create a projection. Gobos are interchangeable discs made of glass or metal with gobo patterns or images that mask part of the light beam while they are mounted on a motorized wheel. They can be mounted on wheels, in fixed or rotating holders. When using gobos, it is important to check the fixture specifications, such as gobo size and thickness. A printed gobo has a dichroic coating on one side only, so it is imperative it is inserted correctly. Otherwise, it is possible to damage the gobo and a good output won't be achieved. Once the light is passed through the gobo and into the lens to be amplified, the projected pattern or image can be focused by moving the focus module in and out to create a hard or soft-edged beam. Gobo animation uses the same techniques as a static gobo, but adds animation effects in the patterns, such as moving clouds or waves. This is achieved by overlapping the static gobo with a much larger rotating gobo animation disc, which is not centered in the light beam. When the beam needs to be split into several beams of the same image, a lens called a prism can be activated, passing through the beam. Prisms are designed to split the beam into 3, 5, or 7 facets to create different effects. Typically, they are combined with a gobo, but can simply be used with an open beam. A prism can rotate, providing even more variation of effect. Something to note is prisms are not used in wash products, because the idea is not to split the beam, but rather to split the light as much as possible. While prisms are great for creating different effects, using a prism diminishes the final output brightness, because every time the beam is split, you are reducing the overall light output. Here's a short clip of Martin prism effects in action. Many higher-end Martin fixtures with a moving head and a moving mirror profile have a motor-driven focus and zoom lens that utilizes a technology referred to as focus tracking. Focus tracking allows the focus to automatically track as the zoom moves. This means the projection can stay in focus even when the fixture is moving around. The majority of Martin fixtures have a zoom and focus lens. However, some may have either a fixed focus or fixed zoom, depending on the value, style, and effect for which the fixture was designed. An example of this might be a fixture that can focus to a certain extent, but does not have the ability to zoom in or out. This must be taken into consideration during the system design phase. Profile beam shaping consists of utilizing a profile's iris to narrow the beam and framing shutters to create sharp lines to provide a wide range of shapes of circular or 3- or 4-sided shapes, which can be used, for example, to highlight a doorway. Different shape effects can also be obtained by using glass with grooves to refract and stretch the light to create an oval. By installing barn doors on the front of the fixture, the illuminated area can be limited. Frost filters can also be added to soften shadows. Using the effect of blurring the edges in this manner is more prevalent in washes because it provides a more even distribution of light, which is why different lens options are available. This concludes this video. We'll see you in the next one. Thanks for watching.